an introduction. Previously, we understood the meaning of rest and motion in the context of physics. However, we did not investigate the causes of rest and motion. We could even ask, do the states of rest and motion require a cause? And if so, what might that cause or causes be? Let us delve into this question together. For a long time, humans believed that the natural state of any object was rest, and that the state of motion could only be achieved via some effort or impetus. But since we have already seen that rest and motion are not special in any way, but depend entirely on our frame of reference, we must also carefully evaluate our understanding of their causes. What exactly is this impetus or effort that we are talking about? The question arises, can we rigorously define why and how objects are brought into a state of motion or rest? And if so, what words should we use in the context of physics? The impetus or the effort needed to achieve a change in the state of an object can be called a force. And when we say this word state, what we refer to is one or more of the following properties of an object. Number one, its condition of rest or motion. Number two, its rate of change of speed. Number three, a change in its physical shape. Number four, the direction of its motion. So in other words, it is not possible to define force outside of the effect that it has on the object under consideration. We can also see that forces can act on the same object in different directions. In a game of tug of war, if both teams pull on the ropes and the forces are equal in magnitude, the positions of the teams will remain the same. If, however, one team manages to apply greater force, the position of the rope will shift. In the first case, the forces are balanced, and in the second case, the forces are unbalanced. It seems obvious that motion would require an unbalanced force to act on an object. In daily life, it is easy to believe that rest is the natural state of being for any object. After all, we never seem to see an object start moving on its own without an external push or pull. On the contrary, a moving object seems to slow down on their own accord without a force being continuously exerted on them. For example, a bicycle moving along a road will slow down to a halt if we don't keep pedaling. A ball thrown in the air slows down, comes to a halt, speeds up again, hits the ground, and then stops eventually. Thus, it seems that continuous application of force is an important prerequisite to motion. And this was indeed what humans believed for thousands of years. It was the view held by Aristotle. But it wasn't until Galileo performed some landmark experiments that the common sense view was challenged.